Hello students. Now we shall look at the coefficient of performance of windmills. If we use that word term Kp, coefficient of performance for a windmill, this is equal to power delivered by the rotor, that is the actual power which is delivered, divided by the maximum power which can be delivered based on the wind. So actual by ideal. So this is Kp, that is P divided by P max. And so what is power here? P maximum power, P max, what can be developed is dependent on density of air, is dependent on the swept area, and dependent on the velocity of the wind. Okay, only three things. The maximum power which can be developed, P max, the relation is P max is equal to 1 by 2 rho into A into V cube, where rho is the density of the air that you will calculate based on the temperature of the air. Second is area, swept area of the turbine, and V is the velocity in meters per second. Second thing is there is something called a TP ratio, tip speed ratio. That is the blades, you have big blades like 50 meters, 100 meters blades, no? So the speed at the blade tip, the blade, because now you just imagine 50 meters or 100 meters, if the blade is rotating, the tip is rotating at the highest speed, hub is rotating at the lowest speed. I am talking in terms of meters per second, okay, not in RPM. Now this tip speed ratio is equal to the blade tip speed velocity divided by the wind velocity. So this Kp, that is the performance coefficient of performance, we can see for various types of wind turbines, that is 7S turbine and Dutch type turbines. Here it is low, and for propeller type turbines it is having the highest value. And one more thing is we are supposed to keep the power to weight ratio. We have to keep the power should be high and the weight should be the lowest. Now you can see this is the coefficient of performance for the windmills. In the y-axis you have got Kp, that is coefficient of performance. Maximum is 0.59. The maximum efficiency of the wind turbine cannot exceed 59%, and that is called as Bed's limit, B-E-T-Z, Bed's limit, okay. And x-axis you have got a tip speed ratio, that is the tip speed of the blade divided by the wind velocity. So you can see the ideal rotor, the curve should be the top one. You can ideal rotor curve should be like this, okay, that is a standard curve. But you can see the 7S and Dutch, they have got very less than 0.2 coefficient of performance, means only 20% efficient there. If the wind has an energy of 100%, so the power which this 7AS or multi-blade or Dutch type turbine can develop is only 20 to 25%. Whereas this, whatever we are having, that horizontal axis wind turbines, propeller ones, 3 blades, they are having almost 40 to 45% efficiency. You can see from the graph, and that is why they are very popular. So this was the coefficient of performance of the wind turbines, and using the same relations for power, like P is equal to half into rho A V cube, this we will be solving some two numericals. So let us see the numericals now. So please remember this graph which speaks of the various types of turbines. So like the ideal rotor should be almost 50-55% efficient, and but it is not the case. The only actual efficiency what we get is almost 40 to 45% in propeller turbines, and less than 20% for Dutch and Savines turbine, and for multi blade it is almost 25%, 22 to 25% efficiency. So this coefficient of performance is plotted against this coefficient of performance versus tip speed ratio. Thank you.